Good morning, everyone. This is the second International Symposium of Transportation Engineering. My name is Ana Paula Furlan, and I am pleased to introduce our today's lecture, Andry Razakamanantsoa and Michael Levert. Andry Razakamanantsoa is a PhD in Environmental Geomechanics from the National Institute of Applied Sciences, located in Lyon, France. Nowadays, he is a researcher in the Laboratory of Geomaterials and Environmental Interactions of Gustave Eiffel University in Nantes, France. He is specialized in porous mechanics, multi-scale study of hydromechanics, and chemical behaviors of geomaterials and durability. His major research topics are geomaterials and soil and atmosphere interactions. Since 2012, he has been collaborating with the National Federation of Public Works and with the Professional Union of French Earthworkers. He leads a scientific project on water saving for dust emissions from paved roads. Michael Levert is a PhD student in the third year of his thesis at the Laboratory of Geomaterials and Environmental Interactions of Gustave University. He graduated as a mechanical engineer from French Engineering School as an métier architect. He also holds a master's degree in civil engineering from Laval University in Canada. After working as an engineer in a quarry for a year, he started his PhD thesis in the topic of dust emissions on earth-moving sites. I'd like to remember you to use the chat on YouTube for comments and questions. And now I invite you both, Andry and Michael, to present your lecture about dust emissions from unpaved roads. Thank you.
Yes. Hello, everybody. Thank you for the invitation, and sorry for the technical problem. So I'm happy to share with you today the topic of research related to dust emission. I'm happy to share with you about the ongoing research that we are performing in our laboratory. So, as presented by Anna previously, I'm Andry Razakamanantsoa. So I'm a researcher in the laboratory team Geomaterials and Environmental Interactions of Université Gustave Eiffel. And to begin my presentation, I would like to tell you shortly about our new laboratory, and after I will come back to the topic, which is the subject of this presentation. So our main topics are talk around earthworks, durability or earth and structure, and the interaction with the environment. So in the context of global warming, the main question that we try to solve is that about resource saving by using the knowledge in terms of engineering geotechnics around the application, which is cities and territories. The main topics of research of our laboratory are focused on interactions in geomaterials, where we try to develop new binders and to reuse materials, mineral and organic. And with these aspects, we use the porous media and coupling hydromechanical and chemical mechanism as method of studies. And about interactions of geomaterials with environment, we are working on mainly on geomaterials and submitted to hydromechanical stress, and also interaction with atmosphere. About that, we use multiphysics coupling, solid mechanics, and fluid mechanics. Our strategy is the main topics of research are the study are performed using pluridisciplinary and multi-scale approach from molecular to field scale. And let's go back to the topic. I want to talk with you today about a part of a study that we have performed on the problematics related to dust emission. The first part of the presentation that I will talk during some minutes are related to the geotechnical aspects of the dust emission and the link with the unpaved road. The main context is about the need in field that actually, if we talk about the earthwork applications, this how to say that professional aspects require the use of an important volume of water for different part of the activities. But the most activity which use main and very important water is dedicated to the dust inhibition. Why the dust inhibition? Because it can cause problem, risk of security and the safety of worker during the activities. But nowadays, the quantity of water that they use in field is not controlled, and the target is to try to reduce water consumption and to try to use a scientific approach to develop different tools that they can be provided to the profession. Many actions was been done and performed, carried out by the professional in earthworks, but all of these actions are good and interesting, but it's not sufficient enough to reduce water consumption. If I give an example, is for example 1 liter per meter cube of moved soil. If we consider that we have 60 meter cube per day for a current earthworks activity, then you can imagine the quantity of water that they consume. But this is an example. But from now, there is no tool to help the professional in earthwork activities to control the use of water. So the problem is about dust inhibition. So I would like to talk a little bit about state of the art related to the dust, because if we take into account the geotechnical definition, we don't have dust, but we can consider fine particles less than 80 micrometer that can be collected from the surface of soil. So if we can consider that this is dust, this can be produced during transport, traffic, mixing process, or soil treatment. In terms of regulation, in France, many regulations are dedicated to the site like quarry, but it's not well clear for earth moving and mobile site in terms of exposure. If I make a kind of a background about the dust emission and to try to identify where is the main sources for dust production, so we can see that we can have dust from compaction or from during a cycle of traffic, or also due to the environmental condition like wind and the things related to that. But from the actual knowledge, there is no knowledge related to the mechanism of dust generation is not well clarified. Okay, how to inhibit the dust emission? From now, there are many techniques, but we can summarize in 3 points: mechanical stabilization, or and the second one is the use of additive like water or another chemical, or and the third one is the use of water. But the use of blender is not recommended because it's not environmental friendly. If I can I make a short summary of a main product that can be a chemical product that can be used for soil treatment to reduce dust inhibition. We can you can see some examples considering the volume of traffic, the type of soil that can be encountered, and the climate during the traffic. We have many types of chemicals, but the problem is that they're almost not environmental friendly, and they are cost also. So it's very expensive regarding to the requirement. So the cheaper one is water, but it's also regarding to the target to reduce water consumption and water resource, so it's become a problem. So let's talk about the scientific gap. Many scientific and technological gap can be told, but regarding to the dust emission, we have selected 3 points. First one is regarding to the reproduction of a magnetic stress governing the dust generation at laboratory scale. And after that, how about the dust initiation condition subjected to the environmental parameters? And the last one is the consideration of dust emission that will be the topic of Michael later. To perform this study, we have selected different types of materials from lab. We have a soil model, and we have also soil from field. We have a mineralogy. We have selected these materials, by the way, to have a fine soil like a clay, but it's not soilable. Okay, there are the soil classification, considering G2R classification in France or ASTM. So we have a fine soil with a low plasticity. So we have soil with a high potential of dust emission. The first point that we try to highlight is about the source of dust generation. For that, we want to investigate a little bit the influence of stress tensor rotation provided by the roller compactor that we can encounter from field. From that, we will see how is it possible to try to apply and to develop this kind of compaction at laboratory scale, and to compare it with a conventional one that we used to have in the lab. As I said, when you consider a compactor, a smooth roller compactor, for example, the smooth roller compactor applies a stress tensor rotation during compaction, and this enhances the settlement of the soil, and you have a compaction at the end. This stress tensor rotation is not easy to perform in the lab, because the conventional laboratory compaction that you have actually is maybe for with dynamic or by static uniaxial compression. So the first question is how to reproduce this method, but in order to understand further about the soil structure provided by this kind of compaction. So we develop a new method which is used for our application, and we applied a different type of level of effort which correspond to the standard smooth roller that we can encounter in field. As a result, regarding the soil structure, the used laboratory rolling compactor allows to provide a similar level of dry unit weight as the standard Proctor, but the difference occurs in terms of pore size distribution, where when we increase the effort of compaction, the roller compaction allows to decrease the macropore size around 10 micrometers. And obviously, the volume of mercury that can be absorbed decrease. If we compare the type of compaction with a conventional method, also we see in the left, we see that a roller compaction method allows to decrease macropore size compared to static and dynamic compaction. You can see from ACM images some examples of a structure obtained with a different type of compaction. If we compare the laboratory representativeness of laboratory rolling compactor from field, we can see in the left pore size distribution from the same material from field and from lab, and you can see that we have the similar pore size distribution, and you can see also in the right that the field smooth roller allow to absorb higher volume of mercury. That means that we have a finer pore, more important in field obtained with field smooth roller. If we take a look about the ACM images, we can see that effectively with smooth roller we have a more well-organized structure, which is favorable for the development of a smaller pore. If we summarize what we have obtained about as information about the compaction, that all type of compaction reduce interaggregate pore from the soil submitted to stress tensor rotation. And another important information is that the aggregate formation is obtained during wetting, and compaction allows only to decrease the macropore size without touching the macropore size, which is inside the aggregate. Let's talk about the next step is since we understand more about the compaction, so let's talk about the interaction between the compacted soil with the wheel during a traffic simulation, for example. So about that, we will talk a little bit about the adherence and the abrasiveness properties of soil against different types of interfaces, and mainly about rubber, because when we talk about traffic, the soil is in permanent contact with rubber during the traffic cycle. And after we will try to see if we have a correlation. We can make a correlation between surface degradation and soil properties. About that, let's talk about the adherence and the abrasiveness. For that, we did a shear box test, unidirectional shear box, and we changed the interfaces. So the first model is to use soil and soil interfaces. It's common that we obviously to have a cohesion and the friction angle. And after we change the interface and we put rubber, steel, and air talon to have different types of interfaces. What you can have in terms of adherence is the ratio between the cohesion with interfaces and the cohesion with soil. Obviously, if you have a value of ratio more than 1, that means that the adherence is more important. So, as you see, with this type of soil, we have an adherence which is higher. If we take a look about the type of soil that we have, the more we increase the sand content, the adherence is higher. It's obvious. And in terms of abrasiveness, what you see is that all of the soils are a kind of abrasiveness level which is close to 1. That means that all configuration tested can be degraded more or less with contact with rubber. After that, we tried to simulate a traffic simulation, cycle of traffic at laboratory scale. For that, we compacted parallelopedic specimen, and for that, we applied different cycle with a smooth roller. We tried to measure settlement, and we collect the particle resulted of traffic, and we did grain size distribution. For that, and ICM observation. For ICM observation, what you see is that the grain collected after a cycle of traffic is mainly composed by aggregates. And if we apply the different series of cycles of traffic, what we observe is that at the beginning we have a very important size of aggregate, and this size of aggregate decrease, as well as the cycle of traffic increases. From that, that means that the abrasion between the rubber of the wheel and the soil increase with time with a number of cycles. We developed for that a degradation index. And as a conclusion, regarding to the compaction, we have the weighting allowed to create the aggregate, and compaction allowed to diminish the space between aggregate without touching the micropore inside the aggregate. And regarding to the soil surface degradation mechanism, what happened at the beginning, you segregate the surface of the soil, you take out the aggregate, and with time, we decrease the size of the aggregates until to have fine particle. So this is the first step of the study. What we have concluded. First point is about we have to investigate more about the influence of wheel print on the soil surface destruction, and after to take into account hydromechanical properties related to the soil drainage during humidification, wetting and drying path. And from now, we tried also to draft a technical guide regarding to the implementation and the soil degradation to help the professional in terms of water saving. So in the overall view, this study, the following steps of the study is to try to take into account the problem of health, which is linked in terms of PM, particle matter emission, and to try to prevent some health problems related to dust emission. So this project is from now, since it was beginning from 2012 until now. We have had 2 PhD students and several masters. We have international patents and scientific papers and a guide in preparation. This ends my presentation, and I would like to give Michael the floor now, and he'll follow about the next topic that we want to present to you. Thank you very much. Excuse me.
Okay. I will take the. I will present the second part. Okay. So I hope you can see my screen. So hi everybody, I'm Michael Leverne. I am a PhD student working with Andry Razakamanantsoa, and I will present you the atmospheric and soil interface, the interaction. And first of all, I will broaden the topic of oil, all the unpaved roads, and after that, I will focus on our recent research undertaken in our lab in the problem. So I will speak about dust, and I will take an overview of unpaved roads in the world. So what is an unpaved road? Andry spoke about that. And unpaved roads, it's a road with no surface coating layer. There is no asphalt, no bituminous material on the surface. So the vehicles they circulate on the aggregates. These roads, they are not paved for economics or practical reason. For economics, for example, low volume roads, there are not enough vehicles circulating onto the surface to make it viable to put a bituminous layer on the surface. So, and also again, for practical reason, for example, in mines or in construction sites, because these roads are temporary. So we not put asphalt layers on temporary roads. So what is an unpaved road? It's a superposition of compacted granular material layers, and vehicles are circulating on the surface course. The surface course is made of aggregates, a mix of aggregates and fine particles. If you have too many aggregates, you cannot compact the road, so it's not good. If you have too many fines, you have a problem of stability and you have too many dust generated. So you have to have a good gradation of the surface course. So I will present you a quick overview of unpaved roads all around the world. The title of this slide, it's a quotation from an article published in Nature in 2014 that say, currently, we are in the most explosive era of road expansion in human history. Instead, at least 25 million kilometers of new roads are anticipated by 2050. It will be an increase of 60% of the worldwide road network compared to 2010. Many of these roads will be built to connect communities and also to provide access to valuable resources such as timber or minerals. And many of the roads which are building are unpaved, particularly to provide access to resources. So here I present you the 6 countries all around the world with the larger road network. First of all, it's the US. It's 37% of the roads in US are unpaved. It's the same amount in India. In Brazil, in your country, it's 89% of the roads which are unpaved. It's a very large amount. It's a very important topic in Brazil. And also in Canada, 60% of the roads are unpaved. So this road, they generate a lot of dust. So what is dust and why is it necessary to limit it? Dust, you know, and we talk about it, we can find a lot of particles into the atmosphere, and the dust particle, they are the fine solid particles remaining suspending into the atmosphere and can be, transported by the wind. Unpaved road emissions are in the range of fugitive dust, which are coarse particles. Coarse particle is between 2.5 and 10 micrometers. We can see on the right the comparison of the size of the particle with a human hair. A human hair, it's almost 50, 70 micrometer in diameter. And we can see the particle of 10 micrometer, the blue one, and the 2.5 micrometer, the red one, very fine particles. And we are taking into account not the real diameter of the particle, but the atmospheric diameter. You can see here a definition. Atmospheric diameter, it's a diameter of a sphere of unit density having the same settling velocity as the particle. So that's it in the literature that we are considering. So where do suspended particles come from? They come from many, many areas, but particularly the combustion, the combustion of wood, the combustion of oil in engine, exhaust of diesel engine, and also dust on the roads, on the unpaved roads, and dust on the construction area, which are mainly, you can see here, coarse particle, between 2.5 and 10 micrometers or above 10 micrometers. Here you can see two figures of the amount of dust generated in the US. In the USA, you can see for the PM10, the particle below 10 micrometers, unpaved roads are responsible of 41.3% of all the particle being raised into suspension. And for the PM2.5, it's 33.7% coming from unpaved roads, so very large amount of particle coming from unpaved roads. And what are the mechanisms of dust emission on unpaved roads? Andry spoke about it. It's a soil degradation by mechanical shear at the tire surface interface. The particles, they are lifted due to the mechanical shear, but also due to the turbulence in the wake of vehicles. The eddies generated by the vehicle circulating on the road. And particles, they are transported by atmospheric turbulence by the wind. So why are we studying dust emission? Because particulate matter, they have health impact. Talk about it. You can see on the right, the penetration of particle. The thinner a particle, the deeper it penetrates into the human body. It can go into the lungs to create silicosis. It's very, very hard disease. So here you can see a quotation from a report of the World Bank in 2011 about the dust emission of unpaved roads, saying that between 1.5 to 2 million people, they die prematurely in the world every year because of high concentration of airborne particulates. So it's very important. And that's why you can see in the table, that's why the World Health Organization, in some parliament, for example, for us, we're in France, we are in the European Parliament, they have some recommendation of allowable threshold of particle into the atmosphere. You can see it's around thousands of micrograms per cubic meter of particle not to be exceeded into the atmosphere. Particulate matter have also environmental impacts. The dust emission, when they deposit, they can deposit on leaves and reduce the plant photosynthesis. It's a problem for agriculture. Here again, a quotation, 26 million hectares of productive lands worldwide are affected by particulate emission, and it reduces the revenue of agriculture, so it's a problem. And the last, but not the least, visibility attenuation by dust particle. You can see here on the graph that there is a link between the amount of particle into the atmosphere and the decreasing visibility, and it can lead to traffic accidents. It's a problem here. Yeah, many accidents in the world because of dust emission, particularly on unpaved roads. And it's also a problem, visibility attenuation, in the mine sector and in construction industry, because it limits productivity. Because we have to decrease the speed of the trucks circulating on the road in mines or in earth-moving sites. So it's a problem of productivity, and it's important to take it into account. So what are the means at our disposal to limit the dust on unpaved roads? We can, first of all, have a good gradation of the surface course, have a good mix of between big particle and small particle, aggregates and fine particles, and to grade the surface with, for example, a motor grader. It's very important to pass very often with a motor grader. We can also use, Andry spoke about it, chemical suppression. Okay, you can use some salts, some resin, some bituminous material to apply on the surface. It's a good solution, it's effective, but it's very expensive and it's not good for the environment. So it's not a very, very good solution. The most common way to limit dust around the world is water, and we speak about it. It's a resource-intensive solution, especially nowadays with climate change and all of the problem with water and precipitation. So it's a problem, especially on construction sites. Here, I give you an example of the problem in France, in the earth-moving professional in France. They want to halve the amount of water used on construction site. Andry spoke about it. The amount of water was around 12 liters of water per cubic meter of earth moving. You know, the earth moving sites, they are quantified in volume, you know, the volume of material moved. So for example, I give you one order of magnitude. One earthwork project, a train line between two cities in France, Paris and Nancy, it was around 49 million cubic meters of earth moving, you know, and it represents 588,000 cubic meters of water applied on the soil to limit dust. So it's a large amount of water. So it's a problem. Dust emission and water using are problematic. So we need to undertake research on this problem. So here I will present to you the device, the apparatus at our disposal to study dust emission. I will then present the state of the art, the emission factors of the United States Environmental Protection Agency. Very, very common use factors, but you know, they are used worldwide, but they have limitation. So it needs to for further research. So I will present you the research works of the Desert Research Institute in the US, and I will present you the work we are undertaken in Université Gustave Eiffel. So the first apparatus, the more commonly used apparatus to measure dust emission is high volume sampler. A high volume sampler is a pump. You know, you suck the air with a particle. The particle comes through the apparatus, and we need to select the size of the particle we want to measure. We can do that with a cascade impactor or a cyclone. Cascade impactor, you separate the particle according to their inertia, and you select the particle you want to measure. With a cyclone, it's the same, but you use centrifugal force. So you select the particle you want to measure, and you collect the particle in a filter. And after the filter, they are weighted after the measurement campaign, so you can have an estimation of the dust emission over a long period of time. But these measurements are not real-time measurements. So for real-time measurement, we use apparatus called spectrometers. How does it work? The air, it's the same. The air is sucked into the apparatus with a pump, and the particle, they came into a measuring chamber, they pass through an electromagnetic wave, typically a laser beam. Okay, we have a laser beam, a light of a laser beam, and the particle, when it comes through the laser, there is a scattering of the light. We measure the scattering angle, and the scattering angle is related to the particle diameter. So we can have an estimation of the size of the particle, and by having estimated their density, we can measure their mass and estimate in real time the concentration of particle being raised into suspension in microgram per cubic meter. So all of these apparatus, they are used worldwide, particularly in the US, to establish, you know, the national ambient air quality standards. For these standards, it's necessary, there is a need to quantify national pollutant emissions, and particularly dust emission pollutant. So for particulate emissions on unpaved roads, they did, in the US, they did measurement campaigns in the 70s, 80s, and 90s, and they established two formulas. One formula to assess the emission on unpaved surface at industrial sites, and one formula for public accessible unpaved roads. So you can see these formula are purely empirical. You know, we have many factors depending on the type of particle and the type of road. But you know, it's very commonly used worldwide. It's a state of the art, but it's purely empirical factors, formulas. So there are so many limitations with these factors. They cannot be generalized around the world. And for example, the dust quantified in this emission, they are horizontal flux with suspended particle, but not with entrained particle, because there is a difference. The particle, you know, they settle. The big particles, they will settle, they will not be entrained into the atmosphere. So there is an importance to take that into account. Also, the emission factors for industrial sites comes from surface coal mining measurements. It's not applicable for our field of research, which is environment, earth-moving sites. So there is a need for further research. And in the earliest of the 21st century, the Desert Research Institute undertake a lot of research in this topic. Here, I give you a non-exhaustive list of communication on the subject. If you are interested, you can read this article. It's very large number of articles. I will just present you some of the development of the DSR Research Institute. They developed new measurement devices. For example, on the left, a device to measure the dust emission directly behind the vehicle tires, to measure the particle torn off by the tire. And also, on the right, you can see dust monitoring towers. So you have a vehicle circulating on an unpaved road, you have a dust plume, and you can measure with different dust track at different height. Dust track is a spectrometer. You will measure in real time the dust emission. You can have an estimation of the dust emission flux. So what are the main findings of these researchers? They found, first of all, that dust emission directly behind the tires, they are related to the cube of the vehicle speed. So when you double the vehicle speed, you will not double the dust emission, you will multiply dust emission by 8. Very important to know that. And also, dust emission flux, they are linearly dependent on vehicle momentum, the speed times the weight of the vehicle. And they're also seasonal dependent. It's important to take into account the meteorological condition. We try to do that in our lab. And also, there is a lack of knowledge about the dust dispersion, so need for further research in this area, and also in the issues of the wake turbulence, the dust emissions, the dust dispersion by the flow generated in the wake of the vehicle circulating. Not well quantified for the moment. So that's why us in Université Gustave Eiffel, we are working on this topic. Andry presented you the Université Gustave Eiffel. So I will be very quick here. We have 3 main research of areas in us. We are working in the land use planning and protection in our lab, and particularly in the research topic of dust emission on earth-moving sites. Andry presented you that. And what is the problem? There is many dust emission by the truck circulation on unpaved roads and intensive watering to limit dust emission. So we think that water savings could be achieved with a better knowledge, with a better comprehension of the mechanism and the condition of dust emission. So that's why we are undertaking research. What we are studying the dust emission, the mechanism from the soil compaction, don't we tell you about that? To its watering, the watering of the soil. We work first of all at the laboratory scale. So we saw we are compacting soil samples in laboratory, with a roller compactor to reproduce the field condition of compaction of the soil in unpaved roads. And we are in the second step, we have a degradation of the soil by a wheel, in a traffic simulator. And what we are interested in is the accumulation of particles on the soil surface. And in the third part, we are studying the lift of the particle because of mechanical shear and aerodynamic forces, typically the turbulence in the wake of the trucks circulating on the unpaved roads. So there is a dust plume generation, and this dust plume generates a visibility attenuation. And this visibility attenuation, we establish a safety criterion in order to know the dust concentration not to be exceeded. And that's when the soil is watered, before have visibility attenuation. So Andry presented you the device we are using in our lab. We are simulating a wheel's pass above soil, above compacted soil. Here we are using different type of tires. You can see the soil samples after thousands of wheel passes. We are interested in the soil surface degradation as a function of the number of wheel passes. The soil surface degradation is the mass of particles torn off by the tire per unit surface area. And here you can see the evolution of the surface degradation for 3 different types of soil. We are also interested in the grain size distribution, and we talked to you about that, or the particle torn off by the tire. Here you can see its grain size distribution. The blue curve is the grain size distribution of the initial soil. This soil, for a clay sand, after this soil, we weight the particle, we compact them, we put on a traffic simulator, and we simulate thousands of wheel passes. After 2,000 wheel passes, we measure the grain size distribution. We establish the yellow curve. After 10,000 passes, we do the same, and we measure the pink curve. After 20 1000 will passes, we have the green curve. So you can see we have an evolution of the grain size distribution as a function of number of will pass. So we establish a model to model the particle crumbling. Particles are crumbled by the share of the will circulating. I will not present the model, it's quite complicated. I will just present to you the results of the model. Here you have a comparison for the grain size distribution of the result of our model, so the dotted line, and the experimental curve, the full lines. And we can see that the model is a good approximation, the evolution of the grain size distribution of the particle torn off by the tire. So the particles, they accumulate onto the soil surface, and we study the lift of the particle. We work in a wind tunnel. We simulate airflow above our soils, or compacted soil degraded by the tires. And we measure, with the device on the right, we measure the flow velocity above the soil. And we can establish some results, some dust emission flux. It's a parameter phi, you can see here, in kilograms per square meter per second. It's a dust emission flux for our 3 different soils and for 2 velocity, for 2 flow velocity, 8 meters per second and 16 meters per second, simulating the wind tunnel. And we work with 3 different number of wheel passes, n equal 100, 1000, or 10,000 wheel passes. What we see here, be careful, the scale is logarithmic. We can see that the high plasticity clay have dust emission many orders of magnitude above the other soils. And also, what we can see here is when we are doubling the flow velocity, we are increasing, we multiply the dust emission by 30. It is not a linear phenomenon. So we work in the laboratory, in the wind tunnel, but we also work in test track. Here I present you some experiments we are doing here. For example, we made circulations of trucks on the particles, and we are measuring environmental condition, the dust emission, and the visibility attenuation. We do that also with passenger car, you see, and we measure the dust plume. That's what we are doing in Université Gustave. And we are also working recently on a wind tunnel with a new device. We are working on the wake of the flow, in the wake of the construction trucks. We are working in wind tunnel with scale model of 2 different type of trucks. And what you can see on the top right corner, it's we put the scale model of a truck in the wind tunnel, and we see the rear of the trailer. And what we are seeing here, it's the turbulence generated by the circulation of the truck. And you can imagine the dust particle being trapped and being transported by these eddies. And with particle image velocimetry algorithm, we can know the flow velocity. You can see on the left, right bottom corner, we can have the flow velocity in real time. So we can assess the dust emission induced by the vehicle. And you can see the average flow velocity of behind the 2 trucks. It's quite different. So it's interesting to work on this topic. Okay, so we are working on that since 2012 in our laboratory. Andry presented you what are our main findings. So here you are what we have published since 2012. And so I will conclude and provide some perspective. The problem of unpaved roads is a very huge problem in the world. Many unpaved roads are in the world and will be constructed in the years to come, particularly in Brazil. And it's a very important topic. A lot of problems with unpaved roads, and among these problems, dust emission is one of the major ones because of health, environmental, and safety issues. So there is a need for research in this topic, and advance in research, advance in knowledge allow a better quantification of this phenomenon. And how us in Université Gustave, we are particularly interested in the research to make it possible to consider water savings, particularly in the construction sites. So I thank you for your attention, and if you have any question, we will be glad to answer it.
Okay, sorry. I'm here now. I'm back. Thank you, guys. Andry, Michael, for your very nice presentation. It was really impressive, and it reminds me about the essential engineering commitment with the economic and social development, you know. So congratulations, Andry and Michael. We know unpaved roads are susceptible to degradation and the weather, the effect of the weather and the climate. But I would like to ask you, Andry, considering that 90%, almost 90% of Brazilian roads are unpaved, what could we do to deal with it? And then where should we start? You know? Your microphone.
Yeah, thank you very much, Anna. It's a great question because, yeah, at the same time, unpaved road is also a richness. It's a wealth because that means that you use a natural materials which is available in around the site, and that means that the regarding to the economy of resources problematics and the topics of research around that, the unpaved road that you have in Brazil is need to be defined in terms of characteristics, geotechnical characteristics first, because as I know, a country like Brazil has a very high amount of lateritic soil and exotic soil. The advanced research that we have done until now and the knowledge that we have until now concern mainly about European soil. So we are interested to share the experiments that we have experienced in France with such type of soil, mainly with natural unpaved road and also with stabilized unpaved road, because the main problem of unpaved road is about durability in terms of sustainability of materials and also in terms of resistance against traffic. And I guess that if you talk about economical development, you think also about transportation. So you think about truck and exchange of trade and something like that. So as I said at the beginning, unpaved road can be considered that as a richness also. And but this richness need to be conserved and need more conservation than paved road. But it's environmental and economic interesting because it can provide job for employees, and also it can enhance the development of research and development aspects in terms of of development of binder, for example, economical and ecological binder, that you know what we do together regarding these topics. And so if you talk about, in one term, if you talk about unpaved road, we have the problem of dust, and we have also the durability in terms of use. So the question that you asked at the beginning is very interesting, but it's also complicated. But as far I'm concerned, I think that I have not a package of a solution, but I have a package of idea and to work together in such problematics which concern the durability, and which concern also the dust inhibition, as we developed at the University of Gustave Eiffel.
Okay, thank you. I think you're inspired and motivated people online. Including myself, I have to ask the question from chat. We have a question from Mateus Silva. He is a student, PhD student here in São Carlos. What do you think to be the most detrimental factor contributing to dust emission from unpaved roads, Andry?
Two main factors. It's very simple: traffic and environmental interaction, mainly season. And it's more important in case of Brazil, because we have at least two seasons, different seasons, where you have a very wet season and a very drought season. And this is the main cause of dust emission and degradation of soil surface.
Okay, thank you. The next question is Michael from André Lapa. He's master's student. We saw that watering is a solution for minor roads and temporary runaways. How could we control dust emission in low volume roads? Which type of solution would you indicate?
Yes, it's not the same problem, because in main roads you can use, you can spread water with some devices around the road. So you're not necessary to apply water with a truck, for example. So it's easier in main roads. You apply a small quantity of water, but you apply it very frequently. It's easy to do it in mine, but you cannot do it in low volume roads. So the better is to use. It's not a very good solution, but you use chemical suppression, because you need to apply water very often, especially in Brazil in summer. I think it's very lot of evaporation, so you will not be able to apply water very often on low volume roads. So often you will not have the money to put asphalt. So many people, they put a chemical suppressant like resin, like bituminous material in small quantities. I think it's the best way, and to reduce the speed. I think this is the best way to reduce the speed, because the speed is the main factors of the emission. And when you double the speed, as I show, you multiply the emission by 8. So yes, it's very important to reduce the speed and have a good gradation of the surface. So to apply frequently, a motor grader will come to, for example, you have routings on unpaved roads to correct the routing problem, because it's an aggravating factor of dust emission also. Route. Open your microphone, Aina.
Sorry. Again, I have another question for you, Michael, about the type of tire. Could you explain a little bit more about the effect of the type of tire on dust emission?
Yes, between the tires, you have some geometry of the tire, and it will increase the shear strength on the surface. So the best is to have the less how can we say that, the less deep structure of the tire. So, but it's not very easy, because the tires, they are manufactured to have a good a good gripping on the soil, to have a good adherence. They are not manufactured to limit dust emissions. There is no research undertaken for tires in this field. So we are working with different type of tire to show the effect. I show you two different tires. They are quite different, but they produce the same amount of particle turnoff. So we are still continuing research in this topic to show the effect of type of tires. But the more sharp is the tire, the more dust it will produce. Yes.
Sorry, I can't hear you. Okay. Thank you. We have another question. I think it's for Andry. It's from Professor Adalberto Tachina. In Brazil, we have, let me see, my microphone is okay. In Brazil, we have two technologies used for dust control: cutback asphalt and asphalt emissions. Cutback asphalts are being gradually replaced by emulsions due to economic and environment reasons. Which technologies are more commonly used in France or in Europe in general?
Excuse me, I would like to give an answer, but it's out of my specialty. So sorry, I cannot give you a correct answer about that, because it's not on my background. Please excuse me.
Just about chemical suppression. In France, we don't use a lot, because we don't have unpaved road in the city road. The only unpaved road we have, it's on earthworks or in mines, and they don't use chemical suppression in mines and earthworks. They only use water, so we don't use chemical suppression in France. Very small amount of them.
What I can say from now is that US companies coming in France from now to propose some product like road rock. It's a kind of a mixture with a polymer which is different to asphalt, but that is the only information that I have in these aspects. And in France, almost all the company of earthwork, they don't like to use chemical products, because they are mainly and severe regulation regarding the use and the environmental impact of such a product. So that is the only information that I can give you in this aspect.
Okay, thank you. Another question from Gustave it was noted that dust emission, mute our microphone. We have a microphone. Yeah, again, sorry. Gustavo Barbosa de Castro asks, it was noticed that dust emissions are seasonal dependent. Is there already any standard that adopts local climate conditions to recommend or not unpaved road applications in terms of cost?
Excuse me, I cannot hear you properly. Can you repeat the question, please, Anna?
Yeah. Let's go. Considering that dust emissions are seasonal dependent, is there already any standard that adopts local climate conditions to recommend or not unpaved roads and road applications in terms of costs? Sorry.
Practically, this is one of the questions that we try to get further information related to the impact, the link between environment and local environment and the behavior of unpaved road. And we have developed some recent tests to try to simulate the behavior of the soils under a different cycle of wetting and drying, which is not like what is proposed by STM, in order to take into account this aspect of seasonality and weathering, and also to try to assess the economic and environmental interest in terms of impact road development. But from now, regarding the information that we have from now and the knowledge that we have, it remains an environmental friendly process, but it needs more further and consideration in terms of how to say that you have to provide more excuse me, in terms of entretien. I missed the word, please. You need more help. You need more, you have to consider more to repair, since it's natural and compacted soil. So you have to repair mainly frequently in comparison with a paved road. But it remains economically interesting and environmentally friendly.
Okay. I think I need to correct the name. Is Guilherme Barbosa Picasso. Sorry, Guilherme. I think that was the last question from Vila Mascarenhas. Congratulations for the presentation. Do you aim to measure the potential impact of human health caused by dust emission? How can we do it? And
yeah, it's a good question. Since I can share something, maybe. I can share, excuse me. To give answer about this interesting question, our attempt is now to make a link between the dust emission and the impact in health in terms of particle matter. And for that, we are involved in the cluster Lang O2 that you can, Lang Innovation, that you can check from the internet, the content. And actually, since several months, we are involved in an option with École Centrale Nantes regarding to the link between environment and health. And just to try to make a link, if we have a link, for example, between the particle matter emission and the pathologic agent which can be involved in this particle. And as you know, the main and well-known problems now is related to the COVID. And in these aspects, we work essentially in terms of aerosol emission. And we try to make a link between aerosol emission and the pathologic agent. I don't know if it's okay to answer to this question.
I think so. I complement this question. I would like to ask you, Andry, if it's possible, or, of course, could you talk a little bit more about your project Saving Water for reduction, for dust emission reduction from unpaved roads?
This project was been initiated since 2012. The main question was to reduce water consumption. And by analyzing the problem, finally, since we are geomechanicians, so we are more useful to work on geomechanics. So finally, we identified a problem related to the geotechniques, which is the dust emission. And finally, it's a problem of shear strength between the surface and the traffic. And from that, we have developed different tools, and we have 2 patents because related to the measurement of soil degradation and environmental impact, because from now you can check there is no more devices which allows us to make a physical modeling of impact of environment on unpaved road and the evolution of behavior of unpaved road submitted to the traffic, considering at the same time the dust emission. And the next aspect that we have developed also is regarding to the fact of the lack of tools to qualify and quantify the ability of soil to generate dust. And we have done a very interesting job also in this aspect, and we have a patent with that. And after these patents, we have from now we have 2 PhD studies, which was the actual PhD of Michael, and the previous one, which is mainly geotechnical aspects. And this is a very interesting topic because we have a combination of soil mechanics and fluid mechanics, and it's very interesting in terms of scientific point of view. And now, actually, we try to make a link with problems related to the environment and health. And we expect that we can give some some interesting solution related to these problems of dust, because obviously we think that dust is a current problem that we have in our house, but it can be a source of many disagreement, like problem of health, or problem also of security and safety if we talk about earthwork. And the next aspect that we expect to work on also is regarding to the energy saving, as presented by Michael, about the structure and track, for example. One of the points that we can work on in the future is regarding to the energy saving in earthwork activities, for example. So from now, it's a good project that we follow till we have the project will be finished in 2022, and we expect to go ahead. Thank you.
Okay, thank you. I think that was the last question. And now I have to thank you two guys, Andry, Michael. It was a great pleasure to have you both here. Very nice presentation. And let me see. I have some comment. Now, I think it's, I think my boss, my chair, Adalberto Faxina, is writing something on chat, but on behalf the undergraduate programs of engineering, transportation engineering, sorry, of the University of São Paulo. I thank you two guys for the really nice presentation, and then I thank you, Carlos, Mateus, and André Lata for supporting this transmission. Thank you and bye-bye. Stay well, and that's it.
Thank you.